All right, in today's lessons, we're going to be working with matrices, we're going to be adding, subtracting matrices, multiplying a matrix by a scalar, and then multiplying matrices. Before we actually get to those operations, we need to discuss what a matrix actually is. A matrix is a rectangular array of terms called elements. All right, and it's important to identify the dimensions of the matrix. The dimensions of the matrix is always the number of rows. All right, the rows are horizontal by the number of columns. Columns are vertical. So the dimensions of the matrix is the number of rows by the number of columns. Rows by columns. All right, so in the first row, first column is in the top left corner. First row, second column, top right. Second row, first column is in the bottom left. Second row, second column is in the bottom right. And then some special matrices. If you just have one row in your matrix, it's called a row matrix. If you just have one column in your matrix, it's called a column matrix. And if you have the same number of rows as columns, then we call that a square matrix. Again, row matrix has one row, column matrix has one column, square matrix has the same number of columns as it has rows. That row matrix is a 1 by 4 matrix. The column matrix is a 4 by 1 matrix. And the square matrix is a 2 by 2 matrix. All right, so let's start with adding matrices. To add matrices, you simply add or subtract the corresponding elements in each matrix. So we're going to add the row and column to the corresponding row and column of the other matrix. All right, so if we have adding these two matrices, we're going to start with the top left corner, first row, first column, 1 plus 5. All right, then the first row, second column, 2 plus 6. Second row, first column, 3 plus 7. Second row, second column, 4 plus 8. All right, when we simplify those expressions, we'll get 6 for that first row, first column, 8 for the first row, second column, 10 for the second row, first column, and 12 for the second row, second column. Notice that the first matrix was a 2 by 2, second was a 2 by 2, and the dimensions have to be the same in order to add or subtract matrices. And the result will also be the same dimensions. The result will also be a 2 by 2 matrix. All right, next is multiplying a matrix by a scalar. To multiply a matrix by a scalar, you simply multiply the number that's in front of the matrix, which is called a scalar, multiply that number by each element of the matrix. So if we've got -2 times this column matrix, we start by multiplying the -2 by the 3 to get -6, and then -2 times the -4 to get 8, and then -2 times the 5 to get -10. The first matrix was a 3 by 1. Our product, once we multiply that matrix by a scalar, it should be the same dimensions, a 3 by 1 matrix also. And then the last skill that we're going to cover today is multiplying two matrices. All right, to multiply two matrices, the number of columns in the first matrix must equal the number of rows in the second matrix. All right, so in this first matrix is a 2 by 3 matrix, 2 rows, 3 columns. The second matrix is a 3 by 2 matrix, 3 rows, 2 columns. All right, those middle numbers are the same. That means that the number of columns in the first matrix is the same as the number of rows in the second matrix. So that lets us know that we can multiply those two matrices. Now, once you multiply the two matrices, the dimensions of the product of those two matrices will always be the outer dimensions. All right, so the outer numbers in those two matrices is 2 and 2. So when we multiply these two matrices, the resulting matrix will be a 2 by 2 matrix. All right, and here's just a breakdown of the process of multiplying matrices. We have these two matrices that we want to multiply. You'll notice that the first matrix is a 2 by 2. The second matrix is a 2 by 3. So the middle numbers are the same, so we can multiply them. And the outer numbers will give us the dimensions of the resulting matrix. The resulting matrix should be a 2 by 3 matrix. All right, so first thing we're going to do is take the first row of the first matrix and multiply it by the first column of the second matrix. So A times E plus B times H. All right, and then we're going to add those products up. We're going to do the same thing. We're going to take the first column of the first matrix, and now we're going to multiply it by, first row of the first matrix, multiply it by the second column of the second matrix. That'll give us A times F plus B times I. And then, again, that same first row of the first matrix, multiply that by the third column of the second matrix. That'll give us A times G plus B times J. Then we're going to do the same thing for the second row of the first matrix. We're going to take the second row of the first matrix, multiply it by each column in the second matrix. When I multiply the second row by the first column of the second matrix, I get C times E plus D times H. And then when I multiply the second row of the first matrix by the second column of the second matrix, I get C times F plus D times I. And then lastly, multiplying the second row of the first matrix by the third column of the second matrix, I get C times G plus D times J. Again, the first matrix was a 2 by 2. Second matrix is a 2 by 3. The middle numbers are the same, so that was what allowed us to multiply those two matrices. And you can see the outer numbers are 2 and 3, so that lets us know that our resulting matrix will be a 2 by 3 matrix. All right, so if we take those two matrices from a couple slides ago and multiply them, this is actually what it would look like. First matrix is a 2 by 3, second is a 3 by 3. So our result will be a 2 by 3 matrix. The middle numbers are the same, so we can multiply them. All right, so when we multiply the first row by the first column of the second matrix, we get 1 times 3 plus -2 times -5 plus 3 times 7. And then multiply the first row times the second column of the second matrix. We get 1 times -4 plus -2 times 6 plus 3 times -8. Now go on to the next row of the first matrix. We're going to multiply that second row of the first matrix by each one of the columns in the second matrix. So 4 times 3 plus 5 times -5 plus -6 times 7. And then the second row of the first matrix times the second column of the second matrix will give us 4 times -4 plus 5 times 6 plus -6 times -8. And then simplify each one of those expressions. We get 3 plus 10 plus 21. -4 minus 12 minus 24. 12 minus 25 minus 42. -16 plus 30 plus 48. And once we simplify those, we should get, for the first row, first column of our answer, 34. First row, second column, -40. second row, first column, negative 55, and then second row, second column, 62. Example 1. We want to subtract these two matrices, so we just subtract the corresponding elements. 0 minus negative 5 is 5. 3 minus negative 5, 3 minus negative 5 is not 2. 3 minus negative 5 should be 8. And then 0 minus negative 5 is 5. Negative 5 minus 3, negative 8. Negative 1 minus 2, negative 3. And negative 3 minus negative 1 should be negative 2. Next example. We're multiplying this matrix, this row matrix, by a scalar. So we just multiply the negative 3 by all the elements in that matrix. Negative 3 times 1 is negative 3. Negative 3 times negative 6 is 18. Negative 3 times negative 2 is 6. Negative 3 times 3 is negative 9. And now we're going to multiply these two matrices. First thing we want to check is make sure that the dimensions are correct, and we can actually multiply these matrices. First matrix is a 3 by 2. Second matrix is a 2 by 2. As you can see, the middle numbers are the same, so we're good to go to multiply these matrices, and our resulting matrix will be a 3 by 2 matrix. All right, so we just repeat that process. First row of the first matrix, multiply that by each one of the columns of the second matrix. So first row times the first column, 4 times 3 plus 2 times 1. First row of the first matrix times the second column of the second matrix gives us 4 times negative 6 plus 2 times negative 2. And then go on to the second row of the first matrix. Multiply that by each column of the second matrix. Second row of the first matrix times the first column of the second matrix is 1 times 3 plus 1 times 1. Second row of the first matrix times the second column of the second matrix, 1 times negative 6 plus 1 times negative 2. And then third row of the first matrix times the first column of the second matrix, negative 6 times 3 plus negative 2 times 1. And then the third row of the first matrix times the second column of the second matrix, negative 6 times negative should be negative 6 times negative 2. Negative 6 times negative 2. Negative 6 times negative 6. Negative 6 times negative 6 plus negative 2 times negative 2. All right, so that will give us, once we simplify those expressions, we should get 12 plus 2, negative 24 minus 4, 3 plus 1, negative 6 minus 2, negative 18 minus 2, and then this one should actually be 36. 36 plus 4. All right, and then once we simplify those expressions, we get 14, negative 28, 4, negative 8, negative 20, and this element should actually be 40. All right. Last example. Last example encompasses everything that we studied in this lesson. So we're going to start by, the order of operation applies to matrices also. So we're going to start by multiplying that first matrix by that scalar 2. When we do that, we will get 0, 4, -2, and -6. Next, we want to multiply the two matrices because multiplying comes before addition and subtracting. So we're going to multiply these two matrices. When we multiply those matrices, we'll get 0 times -2 plus 4 times -2, 0 times 6 plus 4 times 0, -2 times -2 plus -6 times -2, -2 times 6 plus -6 times 0. Simplify those expressions, and we should get -8. 0 times -2 is 0, 4 times -2 is -8, and 0. -2 times -2 is 4, -2 times -2 is 12, 4 plus 12 is 16, and then -2 times 6 is -12, -6 times 0 is 0. And then last thing we're going to do is the adding or subtracting. So when we add the corresponding elements of the matrices, we'll get -8 plus 6, which is -2, 0 plus -3, which is -3, 16 plus -2, which is 14, and -12 plus -3, which is -15.